Thanks, Jason. Good job. Lisa Crozier's next. Give us an update on the sockeye studies that we every few years we kind of add to the recent year's data. So.
Okay, thank you. So today I will be focusing on the adult. Today I'll be focusing on the adult Snake River sockeye migration from Bonneville to the Sawtooth Valley. So this will be in contrast to the other two ESUs migrating through the Columbia about the same time, the Wenatchee and Okanagan ESUs. I'll just refer to them together as the Upper Columbia sockeye for a couple of contrasts, but mostly we're focusing on the fish that are migrating to up to the Sawtooth Valley. They are their adult migration is of particular concern because this was a highly depleted population, essentially extirpated in the 90s, just was maintained through captive broodstock and hatchery production. So we've just been starting to get some anadromous returns since 2008, and those that's an especially difficult migration, not only because of their history, but also because they're migrating during peak summer temperatures through some of the hottest temperatures in the basin through the lower snake and lower salmon, and they have among the longest and steepest migrations of any salmon in this migration. So just in comparison to Chinook, we have the spring Chinook migrating earlier, the later spring summers, and then we have sockeye migrating. They're hitting right when these are Bonneville temperatures, Ice Harbor average temperatures, and temperatures at Whitebird, and the lower salmon. It's just emphasizing that the average temperatures are over 20 degrees during a lot of this migration. Okay, so our project objectives were to first describe detection efficiency at all the main stem dams, then the annual conversion rates between major dam reaches, annual migration characteristics. Today I'll just mention fallback statistics, but in our report we also describe migration timing and travel times between reaches and in comparison to the Upper Columbia sockeye. Then we're going to correlate the migration survival to see what kind of predictors we can use to predict survival in relation to juvenile history, migration characteristics, and environmental conditions as well. We'll conduct the same type of analysis with fallbacks, and the overall context of this analysis is a RPA, which was designed to study the prospects for transporting adult sockeye from Lower Granite Dam up to the hatchery, and the goal was to try to identify some predictors for when transportation might be called for because of expected low survival to the hatchery. Okay, so the database consisted of all fish pit tagged in the, or detected in anywhere in the hydro system, just Snake River here. So we had largest numbers in 2011 and 2015 and has declined since then. Detection efficiency is quite high at most dams, at Bonneville and Lower Granite over 99%, and McNary just a little bit lower, just seeing a little bit more interannual variation at McNary. Ice Harbor had lower detection efficiency overall, in contrast to Chinook and Steelhead. For sockeye, it's dropping down to 93% on average, and 2011 was especially low, 89%. 2017 was the lowest detection year at all dams, and if people in the audience know why that is, I would like to know. There are other high flow years that didn't have the same effect, but at any rate, at the other dams, the Dalles, Lower Monumental, and Little Goose, detection was very, very high, similar to Bonneville and Lower Granite. So for survival, this is a mark recapture analysis using the MARCT program in R. So it accounts for that detection efficiency at those dams. On average, so because 2015 was an especially low survival year, I have in parentheses the average without 2015 and then the average with 2015 in each of these reaches. So generally around 70% through zone 6, but they dropped down to about 65%. 94% about on average to 97% from the short McNary to Ice Harbor range reach, and then usually around 92%, but on average down to 86%, including 2015, and then around 58% from Lower Granite to Sawtooth. Okay, so our criterion for fallback was developed at the Science Center by Tiffani Marsh, and Brian Burke worked on this, and essentially it includes a detection at the within the ladder. We have to be able to detect some upward movement within the ladder, and either a long delay or before a further upward movement or a subsequent detection at a different ladder or a downstream dam. So any fish that was detected backing out of the ladder would not be counted as a fallback. We saw very high rates in 2015, especially at the Dalles and at Lower Monumental. The rates weren't quite as low in 15 at Lower Granite, but they were comparable to that in 2012, 2014. So we're looking at rates around 25 to 30%, and around 15% was fairly common at the Dalles, and occasionally at Ice Harbor, a little lower in other years at McNary and Ice Harbor. In comparison to Upper Columbia sockeye, they never went over 8% and usually under 5%, often under 2%. So huge difference in the fallback rates, even though they're Upper Columbia migrate on average a week earlier, so they're seeing slightly cooler temperatures, but even under the same temperature conditions, definitely lower fallback rates. Okay, so we did just a covariate analysis using generalized linear models to predict survival using criteria for juvenile history or covariates of juvenile history, hatchery versus wild origin. I have to say we didn't have very many wild fish. Almost all of these are hatchery-produced fish. That wasn't a super strong test. Whether the fish had been transported downstream as a juvenile, passage, whether it had been detected in one of the bypass routes, and then the age at return, day of arrival at a dam, whether it had been detected falling back prior to the survival reach of interest or at the beginning of that reach, its travel time through the hydro system prior to the reach of interest. So if you're looking at McNary to Ice Harbor, travel time from Bonneville to McNary as a predictor for survival in the next reach. And catch, there's a major fishery on the Upper Columbia sockeye. So there's, we tracked what the recorded sockeye catch was in the week following passage at Bonneville Dam. We looked at environmental factors at the dam on the day of passage, flow, spill, gas, temperature, and this cumulative temperature time, which is a product of travel time and temperatures measured at the surface where string temperatures were available. We used the top half meter, trying to get at those reservoir temperatures. Otherwise, we use the dam temperatures or water quality monitoring stations. So the results are that the most important variables for survival were temperatures, quadratic effective temperature, history of fallbacks, juvenile transportation, and age. All of those were in all of the top models with anything over 1% of model weight compared by AIC. So these are very consistent predictors. Catch was also a strong predictor. Just summarizing, throwing all of the, 4 of the reaches at you just to show that it's pretty similar across reaches, what the major factors are. Temperature's consistent, fallbacks are consistent. The transportation was mostly an issue in the Columbia River reaches. By the time they make it up to the snake, that's sort of resolved. Lower granite to sawtooth was different. So temperatures measured at lower granite, of course, are affected by the Dvorak cooling. So they're not necessarily predictive of the next 700 kilometers that they have to migrate through the Snake River and Salmon River. Flow was positively correlated with survival. That was especially notable during periods of high temperature. So usually temperature and flow are negatively correlated, but when you do have high temperatures, if there are also high flows, it helped survival, suggesting maybe there's some sort of heterogeneity in there. So it'd be exciting to see the results of more temperature loggers actually in these fish through that reach. Okay, so using those models were pretty good at predicting the observed survival. Let's see. Don't think I'll say anything more about that. The relationship with temperature was essentially that it was pretty flat at the kind of standard temperature ranges that they're migrating at, 16 to 18. But once you get over 20 degrees at Bonneville or in the Snake River, once you're over 21 or 22 degrees, it really drops off very, very quickly. So to conduct the same analysis with fallback, the history of transportation was a very, very strong predictor, and I'll show you how that's related to response to temperature. At the ice harbor, at the Snake River dams, day was a stronger predictor than temperature. Day is correlated with temperature, and additional factors of travel time were important, and then lower granite flow and spill were also important. Okay, so this is the relationship between the probability that a fish will fall back and temperature on the x-axis, and whether they were transported or not. So the fish that had migrated as a juvenile in river had essentially no fallback response to temperature, whereas the ones that had been transported were much more likely to fall back during these, not these extremely high temperatures during the middle of the temperature range. So there's a very strong interaction between transportation and temperature. Okay, so our final objective was to identify metrics that can predict low migration survival and predict in some way trying to characterize how much might be the benefit of transportation under a particular scenario. So I've already argued that temperature is a relatively good predictor, but the question is how to use that in a framework that you might be able to trigger transportation. So the question we asked was, can you predict migration temperatures in advance? So I've shown you that if you know that the temperature an individual fish encounters at the day it passes, you have a pretty good predictor for whether it will survive. But if you want to initiate a transportation program, you want a larger, more average time period that you can use every year to try to anticipate whether the average run will experience that unacceptably high temperatures. And then so if we can forecast the temperatures during the average run, can we use those forecasted temperatures to predict the survival that actually was observed during that year? And then we ran through a particular scenario to see how many more spawners you might get under this scenario. Okay, so the gray bars aren't going to really show up here, but what this graph is showing is different years, the annual migration timing. So this is date on the x-axis, and this is, the early part. The dotted line is the early part of the run, then the interquartile part of the run with the median marked with the dot, and then temperature that was experienced on the x-axis. This is at Bonneville. This is at Ice Harbor. You can't see there's a gray bar in here, but this is showing the interquartile, so the average run period that we used as our temperature that we were trying to predict. And we used this forecast period either 10 days or 20 days prior to that median migration date to see if we could predict temperatures in that period. We did it for both Bonneville and Ice Harbor. Okay, so generally, if you have you're going to have a warm year, you have some advance warning. You can pretty much differentiate the cooler and warmer years about 3 weeks in advance. However, it doesn't work quite as well for actually predicting survival. It does in the extreme years. So this is the temperature period. So it's the time period we were using. Because this is temperature during this advanced time period, and whether and then what the annual survival was. This case, it's from Ice Harbor to Sawtooth. And so generally, you're going to be able to catch the high survival and the low survival years, but there are definitely some anomalous years. 2013 was lower than expected by this predictor, so you might have, if you had not transported in that year, you would have missed the relatively low survival that occurred. And the opposite would have been true in 16 and 17. The survival was a little higher than you might have expected based on this. And the reasons for that are essentially this doesn't account for the variation in run timing. So the individual fish aren't necessarily experiencing these temperatures, and also all the other covariates that we mentioned are important. But certainly you can catch a year like 2015. So the scenario we tried to quantified was if you could grab 20% of the fish passing and they had 80% survival, what would be your increase in the number of spawners? So if you trap them at lower granite, essentially you're really getting your benefit in these 2 years, 2015. If you had transported in 2015, 2013, you get up to 2 to 32% increase in spawners. This is a little hard to read this graph, but lower granite is these green boxes here, and it's sort of this is the proportional increase in spawners with transportation in a given year. You see it really only bumped up in those 2 years. If you survival from Ice Harbor to lower granite is usually pretty good, but in a couple of years, you could have caught that mortality if you had been able to transport from Ice Harbor. So that is shown with these red boxes. A little hard to see these red boxes here. And but if we think about the total migration from Bonneville to this is the cumulative survival from Bonneville, McNary, Ice Harbor, Lower Granite, and Sawtooth. So transporting from Lower Granite to Sawtooth is catching this part of the run, but in a year like 2015, and even in most years, there's only about 60-70% survival through here. So obviously don't currently have any plans to try to collect fish at Bonneville, but I think in the long term, as these are, there's a production hatchery, if they can put out a large number of pit tags, we can do sort by code. I think it's something to start factoring in. With climate change, we're likely to get a lot more years like 2015. So if a lot of that mortality is happening in the lower Columbia River, might want to think about whether we could transport from Bonneville. Okay, so in summary, detection efficiencies are very high, a little bit lower at McNary and Ice Harbor, lower than Chinook and Steelhead. The major factors predicting survival were temperature, history of fallbacks, fish age, juvenile transportation and catch. Similarly, sorry, did I say that? Is that wrong? Anyway, similar factors for fallback, history of juvenile transportation, temperature, cumulative travel time, and previous history of fallbacks. For adult transportation, you can do a reasonable job, I think. You can forecast temperature and low survival years about 3 weeks in advance. It's a modest benefit numerically if you're trying to transport from Lower Granite. However, it could be crucial for broodstock. If you really want to keep anadromous fish in your captive brood program, then even a few fish is going to help that objective. But over the long term, I think might be a good idea, prudent to start thinking about whether at some point you might need to collect them at Bonneville. Any questions?
Questions for Lisa?
Crystal clear.
All right, thank you.